In our previous video, I have discussed how to calculate charges which are appearing on various surfaces of a parallel plate conductor or a parallel plate capacitor. And the fundamental concept that were used was that the total charge on an isolated plate remains constant. Second was the Gauss law, and third was that the electric field within the conductor has to be zero. Uh, in order to determine how this charges appear on various plates, you can see my previous video. The link is given in the description below. So now coming to these four plates, let us assume that a charge q appears on our first plate. So by Gauss law, minus q will appear on second plate. This has been detailed and discussed in my previous video. Similarly, if qa appears on f2r, then from Gauss law, minus qa will appear on f3l. This is based on Gauss law. Similarly, if qb appears on this f3r, then minus qb will appear on this f4l. And I have calculated in my previous video that qt will be same on f1l as well as on f4r. So the value of qt is sum of the charges which were initially given to each plate. That is, initially the first plate was given charge q1, second plate was given charge, this is our first plate, second plate was given charge q2, this is second plate. For third plate, initially it was given charge q3, and fourth plate, initially it was given charge q4. So qt will be sum of all the charges, that is q1 plus q2 plus q3 plus q4 divided by 2. And from the concept that this qt plus q must equals to q1. Similarly, this is based on the concept that net charge on an isolated conductor remains same. So similarly in this case, minus q plus qa equals to q2. Likewise, minus qa plus qb equals to q3, and minus qb plus qt equals to q4. Now in order to determine, because in this case we are interested in determining electric field between 1 and 2, so for I also noticed that I have assumed all this q1, q2, q3, q4 as positive. So, and qt, q, small q, qa and qb are also assumed to be positive. So now, considering electric field between plate 1 and 2, because of this charge qt, if we assume a positive charge over between these two plates, let us assume that we have a positive charge over here. So qt will push this charge towards right. So electric field will be in rightward direction, and its magnitude will be qt divided by 2 epsilon naught a. Similarly, for small q, it will push the positive charge towards right. So electric field will be towards right, and its magnitude will be plus q divided by 2 epsilon naught a. Now this minus q will attract this positive charge towards itself. So electric field again will be towards right. It is shown by this yellow arrow, and its magnitude is plus q divided by 2 epsilon naught a. Similarly, for qa, this charge, I have assumed qa to be positive, so this charge will push this positive charge towards left. So electric field will be towards left, and its magnitude is minus qa divided by 2 epsilon naught a. Likewise, minus qa, this is our minus qa, this minus qa will attract this positive charge, so it will be towards right. So electric field will be towards right, and its magnitude is plus qa divided by 2 epsilon naught a. Likewise, qb will push the positive charge towards left, and its magnitude, so electric field will be towards left, and its magnitude will be minus qb divided by 2 epsilon naught a. And minus qb will attract this positive charge, minus qb is here, it will attract this positive charge, positive test charge. So electric field will be towards right, so its direction will be towards right, and its magnitude is qb divided by 2 epsilon naught a. Finally, qt, this qt will push, this is our qt, this qt will push the charge towards left, So electric field will be towards left. It is shown by this yellow arrow, and its magnitude will be minus qt divided by 2 epsilon naught A. Now notice that these two charges plus qt and minus qt will cancel out. Similarly, minus qa divided by 2 epsilon naught A and plus qa divided by 2 epsilon naught A, this will cancel out. And minus qb divided by 2 epsilon naught A and plus qb divided by 2 epsilon naught A, these two will cancel out. So net electric field between 1 and 2 will be q divided by 2 epsilon naught A plus q divided by 2 epsilon naught A, and that equals to q by epsilon naught A. Now one interesting thing that is to be noticed here is that the electric field between 1 and 2, between plate 1 and 2, is proportional to the value of charges which is appearing on one of the plate. For example, if we are talking about plate 1 and 2, so net electric field is q divided by epsilon naught A, which is propor proportional to the charge which is appearing on one of its face, because by Gauss law this will be equal and opposite. So I am considering only one. So this electric field is q divided by epsilon naught A, and since it is in rightward direction, so potential difference, that is V12, will be E dot dl, and since electric field and dl is in same direction, so V12 will be q into d divided by epsilon naught into A. Now we have calculated electric field between plate 1 and 2. Now coming to plate 2 and 3, suppose we want to calculate electric field between plate 2 and 3. This is our plate 2 and this is our plate 3. So we want to calculate electric field and also the potential difference between plate 2 and 3, and we have assumed a positive test charge over here. Now I have indicated electric field between 2 and 3 as E23. So if we consider this QT, so QT will push this charge towards right, so electric field will be towards right. Similarly, this Q will push the positive charge towards right. The magnitude of this QT is electric field due to this QT is QT divided by 2 epsilon naught A. Now for this small q, this will push the test charge towards right, so its electric field is towards right. It is indicated by this yellow arrow, and its magnitude will be plus q divided by 2 epsilon naught A. For this minus q, it will attract this positive charge toward itself, that its direction will be towards left, and its magnitude will be minus q divided by 2 epsilon naught A. Similarly, QA will push this test charge towards right, so electric field will be towards right, and that is indicated by this green arrow. And for minus QA, this minus QA will attract this positive charge toward itself, so electric field again in this case will be towards right, and its magnitude will be QA divided by 2 epsilon naught A. For QB, it will push the charge towards left, so its direction will be towards left, which is shown by this blue line, and its magnitude is minus QB divided by 2 epsilon naught A. Likewise, minus QB will attract this positive charge toward itself, so its magnitude will be, its direction will be towards right, which is shown again by this blue line, and its magnitude is QB divided by 2 epsilon naught A. Likewise, for the last one, that is QT, it will push the charge towards left. This is our charge, and this is QT. QT is assumed to be positive, so it will push the charge towards left, so its direction will be towards left, and its magnitude is minus QT divided by 2 epsilon naught A. Now again, these QT and minus QT will cancel out. Similarly, Q and minus Q will cancel out, and this minus QB and plus QB will cancel out, so only these two value will remain. So net electric field will be QA divided by 2 epsilon naught A. Again, the point that has to be noticed, that when we are talking about electric field between 2 and 3, then this electric field is proportional to QA, where QA is the charge appearing on one of its face, that is this face F2R, and by Gauss law F3 charge appearing on F3L will be minus QA. So net electric field is proportional to charges which are appearing on faces between these two plates, that is between 2 and 3. And similarly, we can calculate the potential difference. If D is the distance between these two plates, then V23 is QA divided by epsilon naught A multiplied by the distance between them, because E dot dl, E and dl both are in same direction. Likewise, we can calculate electric field between 3 and 4. This I have just, it will again depend on, suppose this is our plate 3 and this is our plate 4. So before going into calculation, we can guess from our previous two calculations that electric field will be proportional to the charges which are appearing between 3 and 4, that is, it will be proportional to QB. Now E34, we can, for QT, if we assume a test charge over here, if we assume a test charge between plate 3 and 4, so QT will push that charge towards right, so electric field will be towards right. Similarly, Q will push, its magnitude will be QT divided by 2 epsilon naught A. Similarly, plus Q, this small q will push the test charge towards right, which is shown by this yellow line, and its magnitude is plus Q divided by 2 epsilon naught A. Likewise, minus Q will attract the positive charge between plate 3 and 4, so its direction will be towards left, and its magnitude is minus Q divided by 2 epsilon naught A. Likewise, for QA, it will push the positive charge towards right, and its magnitude is QA divided by 2 epsilon naught A. Similarly, minus QA will attract the positive charge between plate 3 and 4, so its direction will be towards left, and its magnitude is minus QA divided by 2 epsilon naught A. For QB, notice that this minus sign is not proportional to the charges which are appearing on the plate, but it is the direction in which the electric field will appear. For QB, the electric field is towards right, and I have chosen this positive x direction as positive and negative x direction as negative. So for QB, the electric field is towards right, so its magnitude of electric field is plus QB divided by 2 epsilon naught A. Likewise, for minus QB, notice that here this value comes. If we are considering this minus QB and we have a positive charge over here, so this minus QB will attract this positive charge towards right. So although the charge appearing is minus, but electric field is towards right, so its magnitude will be written as plus QB divided by 2 epsilon naught A. For QT, it will push this negative positive charge towards left, so its direction is towards left, and its value is minus QT divided by 2 epsilon naught A. Now again cancelling out positive and negatives, so this minus QT and plus QT will cancel out, this plus Q and minus Q will cancel out, this plus QA and minus QA will cancel out. So net electric field is QB divided by epsilon naught into A, which we have guessed in the beginning. That is, the electric field between plate 3 and 4 is proportional to the charge which is appearing on the faces between 3 and 4. In this case, the charge appearing is QB. And electric field is in positive x direction, so E dot dl will be positive. And when we calculate this potential difference, then V34 equals to QB divided by epsilon naught into A into D. So from these two videos, I have explained the method to calculate charges which are appearing on various faces of a parallel plate conductor, and as well as the electric field, as well as the potential difference between two plates. Once these theory are understood completely, we can calculate any problem based on parallel plate capacitors. Thank you.